How's it, grade nines? Today we're going on to Pythagoras, working from slides 1 to 21 from the Pythagoras PowerPoint. Now, don't worry about it being 21 slides or 22 slides. It's all revision, basically, from last year with grade 8. So I'm going to go through a couple of examples just to refresh your memory. So before we go into it, I just want you to remember, if you're finding a side, I want you to set up Pythagoras like this. A squared plus b squared equals c squared. Or if you're finding the hypotenuse, I want you to set it up like this. C squared equals a squared plus b squared. And you'll see now with the two examples that I'm going to do how we work that out. Okay. So the first question here is saying, calculate the length of the unknown side. So we have this side here, that side there. This is our unknown side here. And what you need to do is always need to find out which side is your hypotenuse. Okay, and your hypotenuse is always the side opposite the 90 degrees. So as you can see with this example here, here's your 90. The side opposite the 90 is the side here. That is your hypotenuse. And it happens that in this example, our unknown is our hypotenuse. So we come back to this, finding a side or finding the hypotenuse. So we want to find the hypotenuse. So I'm going to set it up like this. And how I set it up, it's going to be your C is always your hypotenuse, and then your A and your B are your other two sides. Exactly the same here. A, B are your two sides, C is your hypotenuse. So for this example here, we're going to find our hypotenuse. And what I want you to do, grade nines, is I want you to label the sides with their letters over here. Okay, so our hypotenuse is BC, so this is going to be BC squared, just using this, equals the two other sides squared. So our two other sides will be AB, AC. So this will be equal to AB squared plus AC squared. Okay, exactly in that form. And because this is geometry, we must give a reason. So our reason here is Pythag. Right, once I've set that up, now I can substitute my values in. So BC is x, so we get here x squared equals AB is 8 squared plus AC is 6 squared. And now I can just work out what this is. 8 squared is 64 plus 6 squared is 36. Add them together and we get x squared is equal to 100. Now remember, to get the x on its own, you need to take the square root. So x here is equal to 10. And I just want to put the units in because they gave us units, so that's centimeters. All right, so not too bad. Going on to the second example. Here they've asked to find the unknown, which is the C, okay? And what I'm going to do is I'm going to find the hypotenuse first, so I know which form of the formula to use. So you remember the hypotenuse is always opposite the 90. So there's our hypotenuse. So we know what our hypotenuse is. So I'm going to use this one over here because we are finding a side. Okay, so it's going to be a squared plus b squared equals c squared. So you remember a squared plus b squared equals c squared. So it is our two sides squared. So I'm going to use qp squared plus our other side, qr squared equals our hypotenuse squared, pr squared. Just put our reason down, which is Pythag. Now I'm just going to substitute my values in. So qp is c squared plus qr is 7 squared equals pr is 25 squared. Just work out what these are. So we get c squared plus 49 is equal to, now 25 squared is 625. Take that to that side and we get c squared is equal to 625 minus 49. And we get c squared is equal to 576. Take the square root on both sides. and we get C is equal to 24. Now, I'm not going to put units in here because they didn't give us units. All right, so not too bad. Right, the next thing I'm going to go on to is determining if a triangle is right angled. Okay, so what they'll do with an example like this, we can see that's 90 degrees, but we don't know, great minds. We have to show it, all right? And how I show it is we have all three sides. So you know that Pythagoras says a squared plus b squared equals c squared. Now, if this equation holds, this must be a 90-degree triangle. So what I'm going to do is I'm going to break it down left-hand side, right-hand side. And what I mean by left-hand side, right-hand side is if you look at the equals and pretend it's like a wall, you see you have the left-hand side of the equals and then the right-hand side of the equals. And if these two sides are equal, then it must hold that Pythag holds, therefore that must be a 90-degree triangle. So let's have a look here. These are our two sides squared, so it's going to be AB and then BC. So AB squared plus BC squared, and our hypotenuse, you can see if that was 90, would be this one here, and that's AC squared. Notice how I haven't set them equal to each other because we don't know if they are going to be equal. We're going to prove that. Okay, so AB is 12 plus BC is 5, and these are both squared. And here we get 144 plus 25, so we get here 169. Now, if I can show that this side is 169, therefore Pythagoras holds, therefore that must be 90 degrees. So AC is 13, and that's squared. 13 squared is 169, sorry, 169. Okay, therefore, left-hand side equals the right-hand side. Therefore, triangle ABC is right angled at B. Okay, so your B will be your 90 degrees. All right, going on to the next example. Okay, so Pythagoras in problems. What they want us to do here is find the length CD, this one over here. So what we're going to do here is we're going to use Pythagoras numerous times to help us find this CD length, okay? For example, if I work in this triangle ABC, you can see I have the two sides there. I can find out what BC is. If I work in the triangle ABD, I have that side and I have that side. I can find the length BD. Now, if I have the length BD and the length BC, I can say BD minus BC, and that will leave us with CD. Okay? So that's my thought process, grade 9s. And I'm going to use Pythag twice here. So the first thing I'm going to do is I'm going to say in triangle ABC. We know that we have the hypotenuse. Remember that this is your hypotenuse. It's opposite the 90. And we want to find out the side over here. So we're going to use the finding the side form of the Pythagoras theorem. So this is BC squared plus BA or AB squared equals AC squared. My reason for this, Pythag. Substitute my values in. So BC we don't know, so I'm going to leave it as BC plus AB is 21 squared equals AC is 29 squared. So BC squared plus 21 squared, 441 equals 29 squared, 841. So BC squared is equal to 841 minus 441. And we get BC squared equals 400. I'm going to take the square root of both sides, and we get 20. So BC is equal to 20. Okay, so now I know what that little length is over there. Now I'm going to say in triangle, now the big one, ABD. Again, our hypotenuse is opposite the 90, which we know, and we want to work out this BD, so we're going to use finding the side form of the Pythagoras theorem. So this is going to be BD squared plus AB squared equals AD squared. My reason for this, Pythag. Fill in my values, so BD I don't know, plus AB we know is 21 squared equals AD is 35 squared. Now, grade 9s, I'm just going to skip a few steps here, just so that I can fit everything on the page, but I'm going to walk you through it. So what I'm going to do on the calculator is I'm going to say 35 squared, and if I take this to the other side, it becomes a minus. Minus 21 squared gives us that number there. So BD squared will be equal to that, but then I need to take the square root. So square root of that, and we get 28. So BD is equal to 28. Okay. So now we know over here that BC plus CD will be equal to BD. So what I did is I said this plus this equals that whole thing. The BC we know, it's 20, plus the CD we don't know, equals the BD we worked out here to be 28. So that means that CD must be equal to 8. I just took the 20 to the other side and it becomes a minus. And that's what they asked us to find. Okay. Moving on to the last example. The last example looks a little bit hectic, but it's not too bad. They're telling us that ABDE is a trapezium. So what that means to us, it means that this side is parallel to this side. And I've marked that with the little arrows. They told us why is angle C1 equal to 90? Okay, angle C1 will be equal to 90 because you have this parallel line, you can make a Z. So alternate angles. So C1 is 90 because of alternate angles. So I'm just going to say here, angle C1 equals 90 degrees. My reason is alternate angles. And I must just state which lines were parallel. So we have AE parallel BD. Okay, that was an easy one. Then they go on to say calculate the length ED. We want to find this length over here. So what I'm going to do is I'm going to work you through my thought process first, and then we can work it out. If I work in this triangle over here, this ABC triangle, I have two sides. I can find this side. Once I've got this side, I can work in this triangle ACE. I have that side, I can work out this side. Once I've got this side, if I work in this triangle ECD, I have that side, I can work out that side. Okay, and you can see with each one of these triangles, they are all 90 degrees. So we can use Pythag for each three. Okay, so in triangle ABC, find our hypotenuse. So our hypotenuse is opposite the 90. So we're finding a side. So here it's AC squared plus BC squared equals AB squared. My reason, Pythag. Fill in my values. So the AC we don't know, plus the BC we know is 10, and the AB we know is 26. All right, grade 10s, grade 9s, I'm going to miss a few steps again. So on the calculator, I'm going to say 26 squared. If I take the 10 to the other side, it becomes a minus 10 squared. We get an answer. Now remember, we must still take the square root of that, and we get 24. So now I know that this length over here is 24. So now I'm going to work in triangle ACE. Find our hypotenuse, which is the side opposite the 90. And as you can see, that's our unknown side. And we have the two other sides. So the hypotenuse squared, so CE squared, equals AC squared plus AE squared. My reason, Pythag. Fill in my values. So CE squared, we don't know, equals AC is 24, plus AE is 18 squared. I'm going to do this all on the calculator again. So we're going to say 24 squared plus 18 squared, get my answer, take the square root, and we get 30. So now I know that this length over here is 30. Now I'm going to work in this triangle ECD, or CDE. Find our hypotenuse, so that's opposite the 90. There's our hypotenuse. So we are finding a side. So it's DE squared plus CE squared equals CD squared. And our reason for that is Pythag. Fill in our values. So DE we don't know, plus CE we know is 30, and CD is 50. I'm going to put everything on my calculator again. So we say 50 squared. If we take the 30 to the other side, it becomes a minus 30 squared. And remember, we must take the square root of that. And we get 40. And we have found out what DE is. All right, grade 9s. Thank you very much.